Hello everyone. So in this module of C++ prep series, we are going to study linear data structures of dynamic type. But before that, let's have a brief introduction to data structures. Well, what is data? Data is basically facts, raw, unorganized facts. Starting from every element in our program, to movies in our laptop, to names of students, their roll number, etc. Everything qualifies as data. Which does give a dead giveaway to our next question. What is data structures? Giving structure to data is data structures. It is a collection of data objects that allows storing, organizing, and retrieving data on systems. It is a way to store and organize data in a computer so that it can be used efficiently. For example, students in a classroom, their data, on what basis they are structured, names, roll number, let's say that. Even every student has further data linked to them as to where they live, their age, their date of birth, and more. Actually, a majority of data structures is inspired from real life scenarios only. For example, arrangement of a leaderboard of a game can be done simply through arrays to store the score and arrange them in a descending order to clearly make out the rank of each player in the game. Or forward and backward surfing in browser, we go from one site to other through various links. Well, they use data structures, a data structure called linked list. As they are linked, when we press the back button, we go to the exact page where we came back from. The music player also uses the same technique to switch between music. Undo operation is also carried out through stack data structure. GPS navigation system also uses shortest path APIs, a huge application of graph. Okay. So before jumping into the types, let's also take a look at what was the reason data structures were introduced. Firstly, we have searching large amounts of data. With a large amount of data being processed and stored, at any given time, our program may be required to search a particular data. If the data is too large and not organized properly, it will take a lot of time to get the required data. When we use data structures to store and organize data, the retrieval of data becomes faster and way more easier. Secondly, speed of processing. Disorganized data may result in slow processing speed, as a lot of time will be wasted in retrieving and just accessing data. If we organize the data properly in a data structure while storing, then we will not waste any time in activities like retrieving and organizing it every time. Instead, we can just concentrate on processing of data to produce the desired output. And finally, multiple simultaneous requests. Many applications these days need to make a simultaneous request to data. These requests should be processed efficiently for applications to run smoothly. If our data is stored just randomly, then we will not be able to process all the concurrent requests simultaneously. So it is a wise decision to arrange the data in a proper data structure so as to minimize the concurrent request turnaround time. There are many more needs which you can find, but these are some of the major ones. Now that we have looked at its needs and real time use, let's study about its classification, its types. We can see that data structures are broadly classified into two types, primitive and non primitive. We will go through each of these nodes one by one, so let's take a look at primitive data types first. Primitive data structures are basic structures and are directly operated upon by machine instructions. These are single storage spaces, and in most programming languages, these data types are available as built-in type. Some examples of it would be int, char, float, pointer, etc. Where int stores whole numbers, float or double as in some programming languages stores fractional numbers, and char stores character values. Notice that a string is not a primitive data structure. Why? because primitive data structure only includes single storage spaces, and a string is actually a character array, that is multiple characters can be stored. And another primitive data type would be pointer. It is a variable that holds memory address of another variable, meaning it always holds only one value. Okay, so moving on to the other side, non-primitive data structure. Unlike primitive data structures, they are not built in, so the user has to define them before using them in a program, as to what type of values will be stored, how many values, and other factors. There are multi-storage spaces that may be homogeneous or heterogeneous. For example, arrays. Arrays in C++ are homogeneous, but in languages like JavaScript, heterogeneous values can also be stored in an array. These user defined data structures are further subdivided into linear and non-linear data structures. For a first, the linear type. As the name suggests, these data structures have all their elements arranged in a linear or sequential fashion. In linear data structure, a single level is involved. Therefore, we can traverse all the elements in single run only. These are multi-storage spaces where the elements are attached to their previous and next adjacent element only. Array is a great example of linear data structure. Linear data structure are easy to implement because computer memory is arranged in a linear way. Now here we can traverse through all the elements by just using a single pointer. Elements can be altered, reversed, and a thousand other operations. In fact, linear data structure has a high application in software development. These linear data structures can be further subdivided into static and dynamic data structures. Now, what is static? It is a data structure of fixed memory size, and once their size is declared at compile time, it cannot be changed. For example, arrays. Yes, the content can be changed, but the size not possible. Element can be deleted, added, updated, but element size, the array size cannot be changed. But even if empty space is there, either null value or garbage value is stored there. That is, capacity remains same. Let's say in a hotel register, we cannot know in advance how many customers will arrive, so we cannot previously specify the size of the chart. It has to change with every customer, right? So we conclude that even though static data structure has its own uses, it comes with a few disadvantages as well. For this, the number of elements to be stored should be known in advance, or else wastage of space or sometimes shortage of space can occur. Also, insertion and deletion are quite difficult in an array as the elements are stored in consecutive memory locations, and shifting operation is quite costly. Therefore, we have dynamic data structure. Yes, it is a bit of a difficult procedure, but I would say its advantages are worth it. So, what is dynamic data structure? It refers to an organization or collection of data in memory that has the flexibility to grow or shrink in size, enabling a programmer to control exactly how much memory is utilized. That is, we can just increase its size during runtime. Even the insertion and deletion procedure is efficient as we do not have to do this shifting operation. Well, this module is all about its types, that is list, or as it is famously known as linked list, stacks, queues. So we'll go over them in the upcoming lectures. Let's just have a brief discussion about the non-linear type. Name suggesting data structures where data elements are not arranged in a sequentially or linearly are called non-linear data structures. In a non-linear data structure, single level is not involved. Its implementation is complex in comparison to linear data structure. Now here a multi-level comes in. Examples would be trees and graph. A tree here. As we can see, there are different levels here. The level 0 is called as root, The one with no further children are called leaf nodes. Here we do not have to necessarily go to the next adjacent index, that is the parents and children do not have adjacent nodes. Well, the terms that I'm using, you may not be familiar with that, but we'll study more about it in detail in upcoming modules. Okay. And finally, a graph. It is clearly visible that it neither does have a typical structure nor a single level or anything. It, in fact, does not even have a specific start point, just like cities in a map, where every city is just a vertex and the path to every other city is a edge. We can move from any city to any other city, provided that there is a path to that city. Okay. Okay, so now that we have seen the various data structures, let's take a look at what we can do with them. That is, operations on different data structures. There are different operations that can be performed for the manipulation of data in every data structure, starting with traversing. Now, traversing a data structure means to visit the elements stored in it. This can be done with any type of data structure. Next comes searching. It is to find a particular element in a data structure. It is considered as successful when required element is found and unsuccessful when it is not. Searching is an operation which we can perform on data structures like our array, linked list, tree, graph, etc. Sorting. Arranging the data in some fashion like ascending, descending, etc. is called sorting, as we know that. And next comes insertion. It is the operation which we apply on all data structures. Insertion means to add an element to a given data structure at any point. Actually, it may be at the start point, middle point, or end point. Okay. Similarly, for deletion, it means to delete an element in a given data structure from similar to the insertion at any point like starting, ending, or middle point. Now, the operation of deletion is successful when the required element is deleted from data structure. That is, the element is found in the data structure and then it is deleted. Okay. Finally, updation. Now, what is updation? As the name suggests, changing values at that particular node as per our requirement is called updation. Okay. Okay, so that was all. So in the next lecture, we'll start with the first linear dynamic data structure, lists. I know this video was a theoretical part, but in the next video, we'll do the exciting stuff, the programming part. So stay tuned for that. And if you liked the video, do like the video, comment, share, and subscribe. And if you have any suggestions, let us know in the comment sections below. Also, the resources used will be given in the description below.